Here's a surface. It's the surface of water. It's different from the water inside, in the bulk. Why is it different? Well, we all know that metal is much more dense than water. That's why it sinks. But what would happen if I carefully placed a piece of metal onto the surface? It's supported. It holds it up. There's a tension in the surface that supports the metal. I could even put a bigger piece of metal on there. It supports that piece of metal too. Here's another example of surface tension. Let me get some of this water, put a few drops onto this wax paper. Now look how strong the surface tension is. I can drag these drops all across this paper without breaking them apart. Put them all together there. Now the water does not wet the wax paper. The forces of attraction between the individual water molecules are stronger than the forces of attraction between the water and the wax paper.
Water molecules inside the liquid pull together in all directions. Surface molecules are pulled only to the side and downward. The sideward and downward forces create a tension on the surface molecules. The water surface acts like an elastic skin.
Is there any way to reduce water's surface tension, to make it wet things better? Well, we can add a chemical that acts on surfaces, a surfactant, plain old detergent. It breaks down the surface tension so that it is no longer strong enough to support the metal. And it's no longer strong enough to hold the drop together. It collapses, and it wets the wax paper.